Hello, my name is Christine Lam, and I'm with Julianna Pledgie and Grace Toman. Our group researched the correlation between annual precipitation and West Nile virus cases in the United States.
Due to anthropogenic climate change, precipitation rates are rising globally, negatively impacting the Earth's spheres. Knowing that mosquitoes rely on water sources for breeding, our research began by asking how this increased precipitation may affect the mosquito breeding and density across the United States. To understand this relationship, we look towards West Nile virus records as a potential indicator of vector density. Our hypothesis is that as precipitation increases, so does the quantity of mosquito breeding habitats, and thus the West Nile virus vector density, allowing for a greater volume of West Nile virus cases per location. This research was also completed to understand how precipitation contributes as one factor of West Nile virus case rates. We hope that from this research, we will be able to identify those states in most need of educational outreach and funding dependent on the relationship defined between precipitation and West Nile virus cases. With these research objectives in mind, we are answering two questions. The first question being, what is the general correlation between annual precipitation and the number of West Nile virus cases recorded in the United States? And the second question being, can this defined correlation then be used to designate U.S. states as most at risk versus least at risk for rising West Nile virus cases in view of the increasing rates of precipitation nationwide?
We collected data from three main sources. The first was the CDC, finding out the amount of West Nile virus cases in each state across the country. Then we collected each state's annual precipitation values from the NOAA. These two data sources provided the numbers that we needed to analyze the relationship between annual precipitation and West Nile virus cases. The last way we collected data was using the globe visualization system to see what areas of the country people are providing information regarding local mosquito habitats. Then we analyzed the data by using the numbers for annual precipitation and annual West Nile virus cases per state, and using the Pearson's correlation coefficient. We found a very weak inverse relationship between these two variables. As shown in the graph, even the line of best fit is skewed by outliers, so we concluded the precipitation should not be taken into account as a way of affecting an area's risk for spread of West Nile virus. So no areas should be given more resources for disease prevention and treatment due to their increase in precipitation. In our analysis of the globe data, we then saw that in more urban areas, there seemed to be more reports of mosquito habitats, like in cities like San Francisco. However, in more rural areas like the Midwestern states, there's a lot less data being reported, and we interpreted this as showing that there's a lot of areas in the country where people are just generally more aware of mosquitoes in their breeding, and some places that might need more outreach and education regarding the spreading of mosquitoes and mosquito-borne diseases.
Our data shows a general weak inverse relationship between annual precipitation and West Nile virus cases. This weak relation cannot be used to make a concrete conclusion, and more environmental modeling will be needed to fully understand this relationship. Research with other variables such as temperature and population density should be fully explored and used in conjunction with the relationship found with precipitation. Additionally, methods for next experiments and research could be improved by focusing on a smaller sample size. With more research, states with the highest risk could be determined and helped by slowing the spread of disease. Furthermore, research could be provided to treat the disease, educate citizens to prevent mosquito breeding, and build better stormwater drainage systems. Before we end, we'd like to thank our sponsors, mentors, and peer mentors who all made this possible. Thank you.